The Collagen Paradox, investigating the biological reality behind the $4 billion supplement hype. The marketing promise is simple. Take collagen for beauty, joints, gut health, and post-workout recovery. The logic sounds intuitive. To build collagen, you must eat collagen. But does that logic actually hold up under clinical scrutiny? Let's find out. First, let's define what we're actually talking about. There are two primary sources. Bovine collagen, derived from cow hides, is rich in type 1 and type 3 collagen. It's the standard choice for gut and joint health. Marine collagen comes from fish skin and scales. It's exclusively type 1, with smaller peptide molecules for higher bioavailability. It's marketed as the premium choice for beauty. Both forms are hydrolyzed, meaning they're pre-broken into peptides for digestion. Now here's what makes collagen chemically unique. Its amino acid fingerprint is unlike any other dietary protein. Glycine dominates at 20.6 grams per 100 grams. Proline sits at 11.5, hydroxyproline at 11.4. This specific triad represents the twisted rope structure of connective tissue. Standard dietary proteins like whey, chicken, or eggs do not possess this extreme skew. And that brings us to glycine, the star of the collagen molecule. 3 key facts. 1. It's the smallest amino acid, and its compact size is what allows the collagen triple helix to coil tightly. 2. It functions as an inhibitory neurotransmitter in the central nervous system. And 3. Glycine is semi-essential. Your body can produce it, but endogenous production often fails to meet full metabolic demand. This is important. It means dietary glycine may not be optional. So here's the hypothesis the supplement industry is built on. Input, a glycine and proline-rich protein. Stimulus, resistance exercise. Expected output, increased connective tissue synthesis. The question is simple. Does the presence of specific building blocks actually amplify the body's repair signal? Researchers put this directly to the test. Oziker and colleagues, published in 2023, ran a controlled trial with 3 groups. Group 1 received 30 grams of whey protein. Group 2 received 30 grams of collagen protein. Group 3 received a non-caloric placebo. All groups performed heavy barbell squats, then were monitored over a 5-hour recovery window with blood draws and muscle biopsies. The absorption data was clear. Plasma glycine spiked dramatically in the collagen group, peaking around 60 minutes. Plasma leucine spiked in the whey group. Both supplements were successfully absorbed. Collagen delivered the bricks, specifically glycine. Whey delivered the signal, specifically leucine. But here's where it gets interesting. For muscle fiber synthesis, the myofibrillar response, whey was the clear winner. Whey significantly boosted muscle fiber synthesis rates. Collagen performed no better than placebo. The contractile machinery of the muscle responded to leucine and essential amino acids, not to glycine and proline. And now the twist that challenges the entire collagen narrative. For connective tissue synthesis, there was no significant effect from any group. Despite high glycine and proline availability in the blood, collagen supplementation did not increase connective tissue protein synthesis rates in the acute post-exercise window. Whey didn't either, neither did placebo. Think of it this way. Collagen gives you the bricks, glycine, proline, hydroxyproline, the raw materials for the structural matrix, but whey gives you the trigger, 3 grams of leucine per dose that activates the mTORC1 pathway. Collagen contains only 0.8 grams of leucine. It has the building materials, but it lacks the signal to start the construction process. This reveals a critical limitation of the study design itself. The measurement window was only 5 hours, but connective tissue doesn't operate on that timeline. It turns over much slower than muscle. While acute ingestion didn't spike synthesis immediately, long-term glycine availability over weeks and months may still be the limiting factor for structural health. The study measured 1 chapter. Real adaptation writes the whole book. And this is where collagen actually wins. Modern diets have a deficit. We no longer eat skin, gristle, or bone broth regularly. Collagen is essentially a delivery system for glycine and proline that whey simply cannot replicate. Its primary use case is supporting the extracellular matrix. Think of it as the chassis of the vehicle, not the engine. Whey builds the engine. Collagen maintains the frame. So what does a strategic nutrition protocol actually look like? Post-workout, in the anabolic window, you need whey protein. It's required for the leucine spike that triggers muscle recovery. Separately, as daily maintenance, you take collagen peptides, 15 to 30 grams taken away from workouts to ensure long-term glycine surplus for joints, skin, and structural turnover. Here's the verdict.